In this presentation, we're going to look at the multiplication of two matrices. So first off, what I have here is a matrix A, B, C, and D, and a matrix U, V, W, and X. Now it's very important in matrices that to consider the order in which matrices are multiplied. If we were to reverse the order, have U, V, W, and X as the first matrix, we would actually get a much different result than what we have here. So ordering is very important. So I'm going to move on now. Here I have some example values. So I'm going to use this as a sort of little example. A matrix 3, 1, 2, and 4 multiplied by a matrix with 2, 5, 4, and 1. Okay. So A directly corresponds to 3. B directly corresponds to 1, and so on. So C corresponds to 2, and D corresponds to 4. Same goes for the other matrix. U corresponds to 2, V corresponds to 5, and W and X correspond to 4 and 1 respectively. So let's commence our multiplication operation. What we're going to do is firstly select the first row of the first matrix. Now I want to be very clear about this, that we're selecting the first row of the first matrix. In this case, we're going to select the first column of the second matrix. So with matrix multiplication for the first row, for the first matrix, we will be using the rows, and the second matrix, we will actually be using the columns. So that's a very important point. So yeah, I have this first column selected there, so I'm going to move on. What we're going to do is calculate a pairwise multiplication and add up all the values. So what I mean by that is the first pair of values, A and U, we multiply them together. We have it here, A, U, and then we will add the next product of the pairs. So the next pair of values is B and W. We multiply them to find their product, BW, and add that to the overall total. So that's our This is how we will construct the first element of our resultant matrix here, AU plus BW. So just to be clear about that, the addition, the sum of the pairwise multiplications. So pick each pair of values, the first pair of values A and U, the second pair of values B and W, and so forth, multiply them and then add them all together. So using our sample numbers here, our example numbers even, we're going to multiply the first pair of values, the 3 and 2, there we have that there. We're going to multiply the second pair of values, 1 and 4, and we're going to add them all up together. So there we have it there, 3 times 2 plus 1 times 4, and that will give us 10 as our answer. So that's the first element of the matrix we're looking for. The second element of the matrix is the first row and second column. Now let's be clear about this. This resultant value here is in the first row and the second column of the resultant matrix. Again, the first pair of values A and V, multiply them together. The second pair of values, B and X, and multiply them together. And then add up all those products together. So we have AV plus BX. Using our values, that is 3 times 5 plus 1 times 1. And that gives us 16. Now I'm going to speed up a little bit here because hopefully at this stage what I'm doing should be very clear. We're going to compute the bottom row of the resultant matrix now. So in this case, we're going to use the bottom row of the first matrix. And we're going to use C and D. This is the bottom row, but it's in the first column. So I'm going to use these two values here. Again, we pick the first pair of values, C and U, multiply them. Then we multiply D and W and add that to our overall total. And we get CU plus DW. And again, using our values, 2 times 2 plus 4 times 4. And we get 20. And finally, for the last element of the resultant matrix, we are going to use the bottom row, the second row, and the second column. We're going to compute the product of each pair and add them all together. So the first pair is C and V. The second pair is D and X. So C times V plus D times X. Using our values, that's 2 times 5 plus 4 times 1, and that gives us 14. So the resultant matrix of the multiplication of those two matrices is 10, 16, 20, and 14.